Picture an archaeological work table. A hand axe sits on the left, scrapers on the right, and tiny flakes fill the trays between them. Every object may be hundreds of thousands of years old. Stare at that table long enough, and an obvious picture forms. Early human technology looks like a box full of stone. That picture displays the materials most likely to last. Wooden handles, digging sticks, spear shafts, containers, fiber, and hide may all have existed when a site was occupied. By the time archaeologists open the ground, most have vanished. The toolkit on the table has already passed through a brutal filter. So half the answer arrives immediately. Stone remains because it survives extremely well, while wood usually does not. That explanation still leaves a harder problem. When a rare piece of ancient wood appears, how can anyone tell that it was once a tool rather than a branch broken by water, pressure, or animals? Begin with the reason wood disappears. A stone tool can be worn, rolled, or broken, yet its mineral body may survive for immense spans of time. Wood feeds microorganisms, burns, splits as moisture changes, and loses worked surfaces to abrasion. Ordinary soil steadily erases the evidence archaeologists would need. A few environments slow that destruction. Long-term waterlogging, oxygen-poor sediment, extreme dryness, or freezing can turn wood into a time capsule. Those conditions are uncommon. Among many sites from the same broad period, one exceptional lakeshore or river deposit may preserve objects that disappeared everywhere else. The result is a powerful visual bias. If a wooden building vanished and only a box of nails remained, no one would decide the building had been made from nails. A prehistoric site creates a similar trap. Abundant stone proves that stone mattered, but stone alone cannot describe the entire technological system. A study published in 2026 makes this problem unusually concrete. Marathousa, one in Greece, was once a lakeshore. Sediments dating to around 430,000 years ago preserved elephant remains, small stone artifacts, worked bone, and abundant wood. Within that material, 2 wooden pieces survive systematic examination as hominin-made objects. The larger object came from alder wood. Researchers identified shaping and use wear on its surface, and its overall form fits a handheld multi-purpose stick, possibly used for digging. The word possibly carries real weight. The marks support a function, but no mark can replay the exact action performed at the lakeshore. The second object was much smaller, made from willow or poplar. It also carries signs of shaping and possible use wear, while its exact purpose remains unknown. Its size matters. Pleistocene woodworking was not limited to spears and heavy clubs. Some tasks may have used tools small enough to hold between the fingers. Another piece from the same collection looks suspicious because deep grooves crossed its surface. Microscopic study attributed those marks to the claws of a large carnivore. The researchers rejected it as a tool. That rejection shows the step popular accounts often skip. Natural damage must be explained before human workmanship is accepted. Marathousa does not remove stone from the scene. The wooden tools lay beside stone flakes, worked bone, and butchered elephant remains. That combination offers a more realistic picture of daily work. The same group engaged with several raw materials, and the material most visible today handled only part of the job. Travel south to Kalambo Falls in Zambia, and waterlogged deposits preserve an even more surprising form of woodworking. Researchers found 2 logs arranged transversely. A deliberate notch had been cut into one so the second could sit across it. The associated sediment dates to at least 476,000 years ago. These logs were more than a convenient branch picked up for a moment. They form the earliest known evidence for structural use of wood. Their finished purpose remains uncertain, perhaps part of a platform, walkway, foundation, or something else, but the notch and fitted arrangement go beyond accidental piling. Younger layers at Kalambo preserved a wedge, digging stick, cut log, and notched branch, dating roughly between 390,000 and 324,000 years ago. Different forms at one site reveal a broad working range. Early woodworkers could shape material from portable tools to large tree trunks rather than repeat one simple design. Those objects survived because river sediments created exceptional conditions. Move the same toolkit to a well-drained upland camp, where soil repeatedly wets and dries, and its wooden parts may disappear. Preservation therefore magnifies certain places and materials while quietly removing others from archaeological counts. Schöningen in northern Germany provides a third picture. Lakeshore deposits around 300,000 years old preserved a range of wooden hunting weapons, including long spears and a carefully worked throwing stick. Here, wood was not a minor attachment to a stone edge. It determined the weapon's length, mass, reach, and use. Direct wooden finds are rare, but stone can preserve a second line of evidence. Some tools from Koobi Fora in Kenya, about 1.5 million years old, carry microscopic polish resembling experimental traces from scraping and sawing wood. The wooden object vanished. The stone edge that worked it retained part of the encounter. Microware cannot identify the finished wooden object. It can indicate the class of material that contacted an edge. Archaeologists strengthen the interpretation by combining polish, residues, tool shape, stratigraphic context, and experiments. Each line narrows the possibilities, though none turns an ancient workshop into a recording. Now consider an ordinary stone implement. Someone may have held it directly or mounted it in a wooden handle with fiber and adhesive. Thousands of years later, the stone remains while the binding and handle disappear. An object displayed alone in a museum may once have been one component in a larger composite tool. Wood also offers properties stone cannot easily provide. A long pole extends reach. A digging stick concentrates force into soil. A handle protects the hand, and large timbers can raise or connect surfaces. Each archaeologic object needs its own evidence, yet these properties explain why wood would reward repeated experimentation. These discoveries invite a new exaggeration. An incomplete stone record does not automatically prove that wood dominated every toolkit. Preserved wooden artifacts remain too few, and their geographic and chronological distribution is far too uneven to calculate a reliable proportion for all early human technology. The term Stone Age remains useful. Stone production left a vast, comparable record, allowing researchers to track raw material choices, knapping methods, and changing tool forms. The problem begins when a technical label becomes a complete picture of life, and the best preserved material is mistaken for the only important material. A vanished wood age can work as a reminder, not as a formal archaeological period. It asks us to reconnect a stone point to a shaft, place worked branches beside scrapers, and return perishable materials to prehistoric camps even when those materials had almost no chance of reaching a museum. Marathousa provides handheld tools. Kalambo preserves a structure and several wooden forms. Schöningen keeps wooden hunting weapons. Stone edges from Koobi Fora retain indirect traces of woodworking. The sites differ in place, age, and evidence, yet together they expose the same missing portion of the archaeological record. The gap changes how technological skill is assessed. Choosing workable wood, controlling splits, cutting notches, finishing surfaces, and combining parts all require experience with material behavior. Once the wood decays, that knowledge leaves no separate fossil. It survives only in rare marks, shapes, and associated tools. Kalambo's structure still has no certain purpose, and the tiny Marathousa tool remains functionally unidentified. Schöningen's weapons are more complete, yet their frequency of use and training practices require inference. Those unknowns do not weaken the finds. They mark the boundary of what the surviving evidence can support. Return to the excavation table. The hand axe, scraper, and flakes still matter, but the picture needs room to expand. Place a wooden handle beside the stone edge. Add a branch being shaped in the foreground. Then restore wooden work surfaces and temporary structures behind it. So why are stone tools almost all that remain? The answer lies in unequal survival. Stone often endures for hundreds of thousands of years. Wood needs unusual conditions to persist. Excavated collections therefore lean towards stone, and our first impression of early technology leans with them. Rare wooden finds illuminate the missing portion for a moment. A probable digging stick around 430,000 years old, joined timbers at least 476,000 years old, and a throwing tool around 300,000 years old restore reach, handles, and structures to that stone-covered table. They enrich the Stone Age rather than erase it. The next time a lone stone tool appears in a display case, one more question becomes worth asking. How was it held, and what might once have been attached to it? The stone may be the complete implement, or merely the one component that survived long enough for us to find. The prehistoric toolkit was never waiting underground as a sealed box for us to open. Time made the first selection, preserving stone and deleting most wood. Archaeology begins by recognizing that selection, then uses every rare wooden survivor to rebuild a tool world that the ground only partly kept.